Welcome, ladies and gentlemen. So we are now on to compound interest, and we're also going to include in compound interest talking about inflation, so how money changes value over time. So our first thing, we're going to look at what is compound interest. So compound interest is where you actually earn interest on your interest. So under the simple interest model, you earn, regardless of how long you invested the money or borrowed money, you're paying the same amount of interest each term. Whereas in compound interest, what happens is we look at what is your closing balance at the end of each term, and then we use that as the new initial for each term afterwards. And David here is very happy to come along and try and help us out. He's looking a little bit bored or angry, I'm not sure, and hopefully he can be cheered up a bit by the end of the lesson. Not sure how we'll go. We'll see what happens. So in our example, we're going to look at $1,000 being invested over 4 years at an interest rate of 10% per annum compounding. So our initial amount of our investment is $1,000. Our interest, remember, we calculate our interest because this is a single term, so I equals PIN. Given n is just 1, because we're creating a table of each term, so it's realistically just I equals PI. So we tend to take 1,000 multiplied by 0.1, or as I say, it's just P times I. So this is going to be $100, so 10% of $1,000. Our final amount here is going to be 1,100. I'm just going to over the side here. So we took our principal and we added our principal plus our interest. And just a bit further to the side here, I'm just going to do a bit of maths and factorize that out. We'll come and we're going to talk about this in a second. So we've got 1,100 as our final amount for our first year. So that's our initial amount for our second year. Our interest, once again, this is our new principal for this term. So it's 1,100 multiplied by our interest rate, which is 0.1. So we're going to have $110. Our final amount is adding these together. So we're going to end up 1,210. For our third term, we're going to start with our 1,210. We're going to take 10% of that, which is $121. We're going to add this on. So we're going to have 1,331. Then our new starting number is our 1,331. 10% of that is $133.10. And now we're going to add this on. So we're going to have $1,464.10. I hope I got that right, as our end amount. So the key thing we can see is that the interest every period is going higher because the base amount we're starting with is getting bigger. So what I'm going to do now is we're going to start to fill in a bit more of this algebra. So this initial value that we start with here was actually our original principal, 1 plus I. And our interest rate was calculated by multiplying these two numbers. So we had the principal times 1 plus I, and by principal I mean the original principal, and then we multiplied that by I again. Then we added this interest rate to our principal. So we said, well, this was the principal outside of 1 plus I, and then we added principal times 1 plus I times I. Now I can factorize that again further, so I could pull my common factor out, and I'll get to the principal outside of 1 plus I, and then what's left would be 1 plus I. And this is repeated, so this actually ends up being the principal 1 plus I squared. Now I'm not going to keep following this through, but as we track through this column, what we're going to get is principal 1 plus I cubed, principal 1 plus I to the power of 4. And the link that we can get here is with our terms, whatever our term number is, the closing balance is just the power at the end of this formula. So if I've got n terms, in the end, my closing balance is going to be the principal 1 plus I to the n. Voila. Where's my ticker? So let's have a look at how these graphs, because we saw how the interest is changing and our principals are growing. So when we compare simple interest, remember, we had straight line. Though when we do our compounding interest, we actually have this curve going up. And so the graphs will look different. This is a linear equation because simple interest is a linear equation, whereas we end up with what's called an exponential graph because compound interest is an exponential function. So our formula, A equals the principal times 1 plus I to the power of n. The same rules apply with compound interest as what we had with simple interest, where when we're looking at these I values and these n values, it has to all be relative to the term that we're looking at. So if the interest rate is in per annum, n has to be in the number of years. If the n term is in numbers of months, for example, and we want to keep it as 3 months, we need to convert this interest rate into a monthly interest rate. And we do that the same as with our simple interest. We just divide by the number of terms. The key word is what is the compounding period? And that's what you need to work in because it will dramatically change your answer. So generally in a question, it will tell you what how often it is compounded. If you're not told, you would always just assume annual compounding. So 12 months is the default. Your compound interest formula, your A equals P 1 plus I to the power of n is on your QCAA formula sheet. So you don't need to remember that formula, but you need to remember what each letter means and that your compounding periods must be common. Final thing, because we don't in this situation necessarily use the A equals, remember we had before A equals P plus I, because there's no formula for I. To calculate I, we then just subtract our principal from our A. So just doing the rearrangement here, subtract I. So principal equals A minus I. And we can get to that endpoint.